Welcome back, students. As you know that our chapter number 12 is over and most of the examples we have discussed already. Now today the time to discuss the exercise question. So in the exercise the 18 questions are given right now. So let us start the exercise questions of the chapter number 12. See the first question. The first question is given: a piece of wire of resistance R, capital R, is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then ratio R divided by R dash is, and the 4 options are given. If the first option, the A option is given 1 upon 25, the option number B is 1 by 5, and the option number C is 5, and the option number D is 25. Right? So let us, I am explaining the question. Again, we have one wire. Suppose we have the one wire of resistance R. Right? And this wire is cut into 5 equal parts. That means, what is the value of the resistance of each part? Because it is cut into equal parts, that is why the equally the resistance will divide. So the each part have the resistance of R by 5, right? R by 5 the resistance there. Now this each part is connected in the parallel combination, right? And when the each part connected in the parallel combination, then the equivalent resistance, the overall resistance offered is become R dash, right? Then that become R dash. So you have to find what is the ratio of R divided by R dash. Right? This is our question. So it is a question which is based upon the series and the parallel combination. So already we have discussed the formula for the series combination and the parallel combination. So let us see the solution. So solution: the resistance of each part of wire is equal to how much? The wire is cut into 5 equal parts. So each part has the resistance of R by 5. Clear? Now these resistances are connected to the parallel combination. So when 5 resistances of resistance R by 5 is connected in parallel combination, then the net resistance is equals to how much? So you know the formula we have discussed already. If the n resistances of the magnitude R, we have the n resistances of the magnitude R is connected in the parallel combination, then the net resistance becomes how much? R by n in the parallel combination, right? Because if you apply the formula 1 upon R net is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, and here the R1, R2, R3 are equal, so you will get here the R by n, right? And similarly you can find if the two resistances are connected in the parallel combination, then how much you will get? R1, R2 of R into R divided by R plus R. So you will get the value R by 2. If the 3, then R by 3. So here the how many resistances are connected? 5 resistances are connected, and the value of each resistance is R by 5. So here the R by 5 is the value of the resistance, and here the value of the n is how much? How many resistances are connected? 5 resistances are connected. So divided by 5. Clear? The each part resistance has the value of R by 5. And how many resistances are connected? The 5 resistances are connected. So this is the value of R here, R by 5, and divided by the number of resistances. So that becomes R by 5 divided by 5. Clear? And the combination resistance is given here R dash. the combination resistance is given R dash. So here the R dash is equals to R divided by, and after simplification you will get 25. Right? R dash is equal to R upon 25. But in the question it is asked, what is the value of R divided by R dash? So you have to find from this expression. From this you will get how much? R divided by R dash. R divided by R dash is equals to 25 divided by 1. Clear? See the options. Option number A is 1 upon 25, so which is wrong. B 1 by 5, which is wrong. C is also 5, which is wrong. And D, C here 25 or the 25 by 1, both are same. So answer number D is correct. Clear? So here, so a simple, by applying the formula of the parallel combination, simply you can find this one, the value of the ratio of the R divided by R dash. Clear? So let us discuss next question. This is the question number 1, right? Exercise question number 1. So let us discuss the second question of the exercise. Let us see the second question. The second question is, which of the following term does not represent electrical power in a circuit? Right? Which of the following term does not represent electrical power in a circuit? And again the 4 options are given. The option number A, I square into R. Option number B, IR square. C, V into I. Or option number D is V square upon R. So you know the basic formula, the first formula of the power is how much? V into I. Right? It is the product of the potential difference and multiplied by the current flowing through the resistor. And when you replace V is equal to IR, so then you will get P is equal to how much? I square into R. In place of V, when you use V is equal to I into R, then I into I become I square into R. Right? According to when you apply the Ohm's law. And the third form, when in place of I you will use V by R. Again you just apply the Ohm's law. Then that becomes V square by R. So these 3 formulas for the power developed across the resistor. So just see here the V into I, the C option, so which is the formula, I square into R, the A option, and V square upon R is the D option. So this our B option is the correct one. Right? IR square is not the form of the power. You see, the term does not represent the electrical power in a circuit. Right? So except this B option, all the 3 A, C and D is the formula for the electrical power. Right? So our answer is the option number B is the correct answer, because there is no formula for the electrical power IR square. Right? IR square is not a formula. Only we have these 3 formulas. Right? So let us discuss the third question. So let us discuss the third question, and this question is very important question right now, because this question is very unique concept is here. You see here, an electrical bulb is rated 220 volt and 100 watt, right? When it is operated on 110 volt, the power consumed will be the option number A 100 watt, the option number B 75 watt, option number C 50 watt, and the option number D is 25 watt. Right now, I am repeating the question. An electrical bulb is rated 220 volt and 100 watt. When it is operated on 110 volt, the power consumed will be. Right? And you have to, these 4 options are given and you have to find which one is the correct answer. Right? Now see what is the physical significance of the power rating. If a bulb is marked 220 volt and 100 watt, what is the physical meaning, physical significance of this rating? See, suppose there is a bulb is here and it is mentioned 220 volt, 100 watt. Right? So first thing, this power rating is indicating the bulb is designed to operate in 220 volt. Right? That means this device, the effective voltage or the permissible voltage which that should be connected to this particular bulb is 220 volt. Right? This is designed for the 220 volt. And if you are connecting this bulb with 220 volt, then the power consumption in unit time, right? The energy consumption in the unit time is 100 watt, right now. So this is the physical significance of this rating, right now. But see here, suppose we have a bulb and this bulb have some power rating of 220 volt and 100 watt, right now. That means it is designed to operate on the 220 volt. But it is compulsory that if you are connecting the bulb not at the 220 volt, then it will not function. If we will connect some other voltage except 220 volt, suppose 250 volt or 200 volt, so whether it will not operate? It will operate, right now. But it is not the effective operation of that bulb, effective operation of the bulb, right now. That means the bulb permissible voltage is given 220 volt, the effective voltage is the 220 volt, but we can connect this bulb with a different power supply, right? We can connect, but maybe the appliances or the bulb is not functioning that much effective because it is designed to operate on the 220 volt. And if it is operating with the 220 volt, then in unit time it will consume 100 watt energy, right now. This is only the physical significance. But there is not the hard and fast rule. If it is the power rating is given 220 volt and the 100 watt, so it is compulsory to connect with the 220 volt. Right? It is not compulsory to connect with the 220 volt supply. We can connect this bulb with any kind of supply. And if we change the voltage, then automatically the power consumption will change, because you know that P is equal to V into I. If you change the V, automatically the value of the current will change. So the product of V into I will also change, right? So if the power rating of the bulb is given 220 volt and the 100 watt, and if you are connecting some other voltage except 220 volt, then this power rating, this power consumption you cannot predict. You have to calculate, right now. So you should be very careful. If it is not mentioned, the operational voltage is not equal to the marked voltage. That means you have to calculate the power. Now see some other aspect. If a bulb is operated in the different power supply, the same bulb is operated 200 volt and the 300 volt, and because of the voltage change, automatically the current will change. So which parameter is constant if you are connecting with the different voltages? Which parameter is constant? If you are connecting with the different supply, so which parameter is still constant if you are changing the voltage? Which parameter? So the resistance of the bulb is constant. Right now, resistance of the bulb is constant. If you are changing the power supply, the resistance is still constant, except all other terms will change. If you are changing the voltage, automatically the current will change. The current will change, then automatically the power consumption will change. Right now? So only one factor is still constant, which is the resistance. Right now? So with the help of power rating, if the power rating of the appliances is given, that means indirectly the resistance of the appliances is given, and which is fixed. Right now? So if the power rating is given, that means you should clearly think that the resistance of the appliance is given. So here the power rating of the bulb is given, that means here the resistance of the bulb is given. So just find out what is the value of the resistance. So solution, the power is given 100 watt and the voltage is given 220 volt. Right? Right? It's a power rating. So with the help of formula P is equal to V square by R, you can find what is the value of the resistance. So here the resistance is equal to V square divided by P. So V square is how much? 2200. So into 2200 divided by, sorry, not 2200, 220. 220 into 220 divided by 100. Clear? So 0 cancel out. So the value of the R is 484 ohm. 22 to the 44, 4, and again to 22 to the 44 plus 4, the 484 ohm. So this is the value of the resistance. Right now? So with the help of power rating, I have calculated the value of the resistance or the resistance offered by the bulb. now you are changing the supply this time. So, but this parameter is constant. Whatever the opposing effect of the bulb, which is constant. Right? So now this time we are operating with the 110 volt. Now we are not using the 220 volt. And mostly students are making the mistake. They are thinking the supply is 220 volt, then the power consumption is, or the heat consumption in unit time is 100 watt. Right? So if the supply is C in the half, 220 volt, so it is 110 volt. So just apply the unitary method. If the 220 volt supply consumes the 100 watt, then 110 volt just half. That means 50 watt. Suddenly they will take the option number C. Right? A unitary method. But let us find out the final answer. After that we will check whether it is obeying the unitary method or not. Right? The C. You see here. So we have calculated the value of the resistance. Now the new resistance is how much? 484, and the voltage is this time is how much? V dash, and the new supply is 110 volt in the given the question. Now we are connecting the bulb with the 110 volt supply, and we have to find the new power. Right? P dash is what? Again, we know the formula P is equal to V square by R. Just apply the formula. So P dash is equal to V square. So this time 110 into 110 divided by the value of the resistance. R is 484. So I am writing it is 484 like 22 into 22. Right? Because again here the 22 into 22 is written 484. So for the simplification, I am writing again 22 into 22. Right? So here you will cut 11 10 ja 110 2 times. 10 2 times. 2 5 ja 2 5 ja. So what is the value? Value is the new power is how much? 25 watt. See here. If you are connecting the bulb with the 110 volt supply, then the power is coming is 25 watt. So whether it is obeying the unitary method, 220 volt consuming 100 watt, then 110 is consuming 25 watt. Right? So it is not obeying the unitary method. So mostly students are making the mistake, they are obeying, just following the unitary method. Right? So it is not unitary method. If the power rating is given, then the value of the resistance is known. Right? So whenever any numerical, the power rating is given, you should very assured on that. If the power rating is given, that means the value of the resistance is given. Except resistance, all the values are changeable. If you are changing the supply, all the values will change except the resistance of the appliances. Right? So you should be very careful for that. And it is not obeying the unitary method. Right? So here the answer is 25 watt. That means the option number D. Right? So this question is very important. So if you have any doubt in this type of question, the variety of questions are given in the different side books, and mostly students are making the mistake. They are just they are thinking the unitary method here, right? The unitary method, 220 volt, 100 watt, 110 volt, 50 watt, right? But it is wrong. Already I have given the solution, so don't be apply the unitary method here. Just find the value of the resistance, and with the value of the resistance, just apply the formula for the power or the heat, whatever the values are given in the question. Right now, then you can find the value of this one. So this is your question number 3. Right now, these are very important. So I hope you understand these questions. Right now, in the next class, we will discuss some other question of the exercise. Right now, so if you have any doubt, mention in the comment section. Thank you.